Ladies and gentlemen, welcome to another interesting episode of the Triune Physics, aka Physics Bible, the measurement of temperature part 2. From our previous episode, we were able to establish the individualistic formulas for Celsius, Kelvin, Fahrenheit, and even unknown thermometer. Please refer to the link displayed on your screen for better understanding. If you know that you've missed that episode, please, for better understanding. So let's dive right in. In today's episode, we'll be dealing with the interrelationship between the various scales. In order to find the value of the unknown temperature using any two of the thermometers, we will be following some particular method. But before we apply that method, you should understand that the triune thermometers used for basic temperature measurement are number 1, Celsius scale or centigrade scale thermometer. Then we have the Fahrenheit scale, the thermometer that reads Fahrenheit. And then we have the absolute Kelvin. These are the three most commonest thermometers being used, and I term that to be the triune thermometers. Then we also have the triune temperature measurement points. The triune temperature measurement points. We have number 1, the lower fixed point, which is T of O, which is also the ice point or the melting point. Then we have the number 2, the upper fixed point, which is the T100. The upper fixed point, the steam point or the boiling point. And then number 3 is the unknown point. That is the unknown temperature value that must be calculated or measured. It is known as T of X. Is that clear? So from our previous episode, we were able to establish the following. That the Celsius scale, we use T of E to represent that. And the formula was T of E divided by 100. It gave us equation 1. Then for Fahrenheit scale, we use T of P to represent that and give us T of P negative 32 over 180, which gives us equation 2. And then absolute Kelvin is T of K, which is TK negative 273 divided by 100. It gives us equation 3. And then the unknown thermometer, let's assume the resistance thermometer measured in ohms or others. It is known as T of X, and the formula is T of X negative X of O, which is X naught divided by X 100 negative X naught. It gave us equation 4. So quickly, let's delve deeply into the interrelationship between the various scales. It means the conversion from one scale to another. From your screen, what do you see? The first is the Celsius scale or the Celsius thermometer. And you can see T of O representing the lower fixed point and T of 100 representing the upper fixed point. Is that clear? Then the next thermometer is the Fahrenheit scale. Is that clear? You can see the liquid or thermometric liquid rising inside the thermometer. The lower fixed point is 32 and then the upper fixed point is 212 for Fahrenheit scale, degree Fahrenheit. Please take note of that. Then the third triune thermometer is the absolute Kelvin. The thermometric liquid you can see is rising in purple. The lower fixed point is 273 and the upper fixed point is 373. The unknown temperature value is T of K. T of K, please take note of that. Then the fourth is the unknown temperature with the lower fixed point at X naught and the upper fixed point at 100. That is X of 100. And then the thermometric liquid is in blue, rising within the tube. Then the unknown temperature value that will be calculated will become T of X. Are we together? So the red line here at the bottom of your screen denotes the lower fixed point. Is that clear? Lower fixed point. Then the blue line denotes the upper fixed point. Are we together? It denotes the starting point and the ending point, the point of origin and the point of termination. The differences gives you distance and gives you 100 equal divisions. Then the line at the center is for the unknown temperature. You can see we use that to calculate for the unknown. Is that clear? Please take note of this diagram. So this diagram is the interrelationship between the various scales, 4 of them. The first, the second, the third, and the fourth, all denoting or representing Celsius scale, Fahrenheit scale, Kelvin, absolute Kelvin, and unknown thermometer or temperature. Please take note of that. With this, you understand that if you are asked to convert from any of these temperature value to another, all you need to do is to establish your lower fixed point, establish your upper fixed point, relate them to the other thermometer, and you are good to go. Ladies and gentlemen, in order to find the value of the unknown temperature using any of the 2 thermometers, from the previous episode, you know that we said that T of E represents Celsius scale. Is that clear? And it's given by T of E divided by 100. And it gave us equation 1, degrees Celsius or centigrade. Then for Fahrenheit scale, we use T of P to represent that, and is equal to T of P negative 32, okay, divided by 180, equation 2. Take note of that. Then absolute Kelvin, we use T of K to represent that, and is equal to T of K negative 273 divided by 100, equation 3. Then for unknown thermometer, we use T of X to represent that, and is equal to T of X negative X of O divided by X of 100 negative X of O. Take note of that, equation 4. So let's begin properly now. Conversion between Celsius degree to Fahrenheit. Let's equate equation 1 and 2 together so that we'll have T of E divided by 100 will equal T of P negative 32 over 180. So that will cross multiply, and then T of E multiply 180 is equal to 100 into T of P minus 32. Let's divide through. Let's divide through by 180 so that we have T of E is equal to 100 over 180 into T of P negative 32. Is that clear? Then 100 divided by 180, if you say 20 into that, you know that T of E is equal to 5 over 9 into T of P minus 32. Equation 5. Take note of that. Or T of P, if we are making that formula, will become T of E multiplied by 180 is equal to 100 into T of P minus 32. Let's divide through now by 100 so that we have T of E multiplied by 180 is divided by 100 is equal to T of P minus 32. So that T of P will now equal T of E multiplied by 180 divided by 100, which is 5/9 plus 32. This gives us equation 6. So remember that T of P is in Fahrenheit and then T of E is in degrees Celsius. Take note of that. Then, if you are asked to convert from Kelvin to degrees Celsius or vice versa, we equate equation 3 and 1 together. Is that clear? So that equation 3 gives us T of K negative 273 divided by 100 is equal to T of E over 100. Let's cross multiply so that you have what? Cross multiply 100 T of E is equal to 100 into T of K negative 273. Close your bracket. We'll divide through by 100. Is that clear? So that 100 cancels 100. T of E is equal to T of K negative 273. Is that clear? This is conversion to degree Celsius or centigrade, or T of K is equal to T of E plus 273. Is that clear? This is absolute Kelvin. So this is how the equation comes about, or the formula, where T of E is in degrees Celsius, T of K is in absolute Kelvin. Take note of this, please. Then let's proceed. What about if you are converting from conversion between degrees Celsius and the unknown temperature or unknown thermometer? Then we will equate equation 1 to 4. Is that clear? So that our T of E divided by 100 will equal T of X negative X naught over X 100 negative X naught. Is that clear? So that when you cross multiply, you have T of E into X 100 negative X naught is equal to 100 into T of X negative X naught. Let's divide through by X 100 negative X naught, so that you have T of E into X 100 negative X naught divided by X 100 negative X naught is equal to 100 into Tx negative X naught divided by X 100 negative X naught, so that X naught will cancel that part, and then T of E will now equal 100 into Tx negative X naught divided by X 100 negative X naught. Is that clear? So that this X naught can cancel X naught, or you can have T of E is equal to 100 into T of X over X 100. This is when you are converting from degrees Celsius to unknown thermometer. Is that clear? Take note of these. I hope you are following. Now, let's proceed further. Or if you are asked to calculate for the temperature of the unknown thermometer, then you have T of E into X 100 negative X naught is equal to 100 into T of X minus X naught. So let's divide through by 100. Divide through by 100. So that you have T of E into X 100 minus x naught divided by 100 is equal to T of x negative x naught. Okay, so that T of x is equal to T of e into x 100 negative x naught divided by 100 plus x naught. Take note of this. That is if you are asked to convert from degrees Celsius to unknown temperature and you are asked to find the unknown temperature. Hence you use that formula or equation. Now conversion from degree Fahrenheit to Kelvin, absolute Kelvin. Now we are going to equate equation 2 and 3 together. So that from equation 2 you have T of P negative 32 over 180 is equal to T of K negative 273 divided by 100. Let's cross multiply, where T of P is equal to degree Fahrenheit. Please take note of this. Don't get this confused. Take note of what T of P stands for. Let's cross multiply now, so that T of P minus 32 all in bracket into 100 is equal to 180 into T of K minus 273. Is that clear? So let's divide through by 100, so that 100 cancel out 100. Then T of P, okay, T of P minus 32 will equal 180 divided by 100 into T of K negative 273. Is that clear? Let's close our bracket, so that T of P negative 32 will equal 9 over 5 into T of K negative 273. Please, 20 into 180 and 100 is 9 over 5. T of P is equal to 9 over 5 into T of K negative 273 plus 32. Is that clear? Or we can also say that T of K, if you are asked to make T of K the soil formula or to find absolute temperature, then T of P minus 32 is equal to 180 over 100 into T of K negative 273. Close that bracket. Our goal is to make T of K the soil formula, so that we'll now have T of P minus 32 is equal to 9 over 5 into T of K minus 273. Cross multiply. Okay, so that our 5 into T of P minus 32 is equal to 9 into T of K negative 273. Close bracket, so that we divide through by 9. So that 5 over 9 into T of P minus 32 will equal T of K negative 273. Is that clear? T of K will now equal 5 divided by 9 into T of P negative 32 plus 273. Take note of this. If you're asked to find T of K, you use this when it is related to degree Fahrenheit. And then T of P, okay, is equal to that. Let's proceed. Conversion from, let's say, degree Fahrenheit to unknown temperature, or vice versa, which is X. Then we would equate equation 2 and 4 together. Is that clear? From equation 2 we have T of P representing degree Fahrenheit negative 32 over 180 is equal to T of X negative X naught over X 100 negative X naught. Is that clear? So that when you cross multiply, we're gonna have T P negative 32 into X 100 negative X naught close bracket is equal to 180 into t of x negative x naught. Is that clear? So that divide through by 180, so that tp negative 32 into x100 negative x naught divided by 180 is equal to t of x negative x naught. Is that clear? Then t of x is equal to t of p negative 32, okay, into x100 negative x naught divided by 180. Is that clear? Positive x naught. Please take note of these. This is another equation for you that is applicable to this. If you are asked to convert from t of p minus 32 into x100 negative x naught, you have this is equal to 180 into t of x negative x naught. Is that clear? So that we divide through by x100 negative x naught. Is that clear? So that we'll have t of p negative 32 is equal to 180 into t of x negative 1 x naught divided by x100 negative x naught. Is that clear? So that t of p is equal to 32 plus 180 into t of x negative x naught divided by, close this bracket, x100 negative x naught. Is that clear? Please, all in brackets. Or we can say t of p is equal to 32 plus 180 into t of x over x100. Take note of these. So you can use this to calculate 4 degree Fahrenheit to unknown temperature. Please take note of these. Next, conversion between absolute Kelvin and unknown temperature or thermometer. Is that clear? This can be in ohms or any other value. So we equate equation 3 and 4 together. Hence, we have t of k is equal to, t of k negative 273 divided by 100 is equal to t of x negative x naught divided by x100 negative x naught. Is that clear? You cross multiply so that t of k negative 273 into x100 negative x naught will equal 100 into t of x negative x naught. Is that clear? Don't forget that we cross multiplied in order to obtain the next step. Don't forget that, please. We simply cross multiply so that if t of k negative 273 is equal to 100 into t of x negative x naught, we divide through by x 100 negative x naught. Is that clear? So that t of k will equal 100 into t of x negative x naught divided by x 100 negative x naught plus 273. Is that clear? So take note of this, please. Alright? Or if you ask to find t of x, then t of x unknown temperature will equal tk negative 273 into x100 negative x naught is equal to 100 into t of x negative x naught. Is that clear? We'll divide through now. Divide through by 100 so that t of k negative 273 into x100 negative x naught divided by 100 is equal to t of x negative x naught. When 100 cancels out 100. Is that clear? so that we have T of x is equal to T of k negative 273 divided by 100 multiplied by x 100 negative x naught divided by T of x negative x naught. Is that clear? So this gives you another equation. X naught can cancel out x naught. Please take note of that. Connect to our social media handles at Physics Bible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.